VTP, pretty simple discussion here. I'm not going to spend a whole lot of time on VTP. It is a Cisco proprietary protocol. The whole goal of VTP is to make it easier for us to propagate VLAN information across the network. Essentially what VTP does is it copies the VLAN.dat file to other switches that are in the VTP domain. And we've already seen the vulnerability of VTP because of the way VTP works, we can actually get copies of databases and overwrite databases. You can see the benefit of VTP, adding 20 or 30 VLANs to switch 1. If those VLANs propagate automatically to the other switches in the same domain, that's nice because then we have consistent VLAN numbers and consistent VLAN names. But as with anything that's automatic, it does open up some vulnerabilities. Because VTP is a layer 2 protocol, it does not go through routers. So you would have to have 2 separate VTP domains in this case. All right. VTP is a data link layer protocol. It's Cisco proprietary. VTP advertisements allow the propagation and the replication of VLAN.dat. We send out VTP advertisements on a periodic basis. Every 5 minutes, these advertisements go out. They're layer 2 multicast frames that get sent out carrying the VLAN.dat information. If there is a change to the VLAN database, they're triggered updates, which means they go out automatically as soon as the change is made. All right? Now, there's a very important aspect to a VTP advertisement that the switches look at. Does anybody know what that is? It's called a revision number. In VTP, there's a revision number. Switches synchronize to VLAN information based on that revision number. We'll talk about that in a couple of slides here. 3 modes of VTP, server, client, and transparent. You were correct, of course. Server is the default mode, which makes VTP quite vulnerable. And as it says there to the second to last bullet point, the default configuration of VTP opens massive vulnerabilities to your switch network, which I demonstrated very easily in Packet Tracer. Overwriting the VLAN database, getting a copy of the VLAN database. VTP only runs over trunk links. It does not run over access ports. All right? VTP, when it starts out, starts at revision number 0. It's a 32-bit number, so the revision number can go up to a very large number, and then it rolls over after it reaches that maximum value. Every time you add a VLAN to the database, delete a VLAN from the database, or rename a VLAN, that increments that revision number. And like I said, the switches actually keep track of their database based on that revision number. What does not increment that revision number? What kind of VLAN configurations do not affect VTP? The stuff you do on the interfaces. Assigning a port to a VLAN does not affect VTP. Creating a trunk link does not affect VTP. It's only when you're modifying the databases when VTP is affected.
So if you go to the database and rename a VLAN, is that going to increment?
Yep. Renaming a VLAN does affect the database, so that will increment the number and trigger an update. Each time, each VTP device, a switch, right, that's going to track that configuration revision number. Here's how it works. You and I are in the same VTP domain. You're a server, I'm a server. We're both synchronized to revision number 10. I update a VLAN in my database, I go to revision 11, I send out an update. You receive that update, you compare it to your revision, because mine is higher, you synchronize to that new version. Make sense? So ultimately, everybody synchronizes to the same revision number. If I receive a revision that's the same, I ignore it. If I receive a revision that's lower, I ignore it. I only synchronize to revisions that are higher. Okay? Says there in the last bullet point, clients and servers compare the received advertisement, and if the received revision is higher than the current revision, the switch synchronizes. One thing that's important to note, though, is that BTP domains have to match. Just because I receive an advertisement, if it's not from my domain, I ignore it. All right? We'll see how we can influence these configurations and all the different configuration steps in this chapter. I mean, we're actually almost done with this chapter. It's a very, very short chapter. All right? So a VTP domain is just a group of switches that are participating in the same VTP process. All switches in the domain share a VLAN configuration. Now, let me ask you guys a question. You saw me set the VTP domain name on my attacker switch, right? I just set it to Cisco. Your domain wasn't set because the default domain name is nothing. So what happened when I plugged my attacker switch into the network? I was sending out VTP advertisements. You joined my domain automatically. That's another vulnerability in VTP. If the domain name is nothing, you will join the very first domain you see automatically. And that's exactly what happened. I plugged into you. You're not running, you don't have VTP configured, so you're a server in null. You join my domain. We share information. I get a copy of your database. That's the way it works. Once the domain is set, it can only be manually changed. But initially, the domain is nothing. So if a switch sees a domain name, an advertisement with a domain, it will just automatically join that domain. It's ridiculous, quite honestly. But Cisco can't do everything right, I suppose. For a switch to participate in a VTP-enabled network, they have to be in the same domain. The domain name does propagate, and any client or server without a domain name set automatically joins the domain that's advertised. There is an exception to that, right? The exception to that is if you're not using VTP passwords, or if you are using VTP passwords. If a password is set, it won't synchronize because it doesn't know the password. But, all right, how do we set the domain name? Global command, VTP domain, Cisco 1. So if I was to go into switch 1, or whatever name you want, if I was to go into switch 1 and type VTP domain Cisco 1, that would change the database because the VTP information is also stored in VLAN.dat. That would change the database, which would trigger an update, and all these switches would join that domain automatically. So I'm pushing out my domain name to the switches that don't have a domain configured. Assuming, of course, that those links between the switches are what? Trunks. They have to be trunks. VTP only runs over trunk links. All right? Let's talk about the modes of operation. 3 modes of operation. The default mode is server. The recommended mode is transparent. And that is recommended by Cisco. It's amazing. Why don't they just change the code and make it transparent by default, right? But they don't. There's a reason why transparent mode is the preferred mode of operation. It's the preferred mode of operation because it's the most secure mode. And we'll talk about why that's the case here in a second. To change the mode of operation, it's a global configuration command. You simply type VTP mode and then specify the mode that you want to run. Whether it's server, client, transparent, doesn't matter. Now I'm going to describe to you what the difference is. A server sends out advertisements. A server synchronizes with the domain. And a server updates its database. I guess that's the same thing as well, I was going to say, a server can update another server, and a server can update a client. Okay? Clients synchronize to the domain. Clients send out advertisements. Clients can update other clients, and clients can update servers. So a client and a server are the same thing, but there must be a difference, right? If I switch my switch to client mode, I'm going to show you what the difference is right now. If I switch my switch to client mode, VTP mode client, VLAN 20, VTP VLAN configuration is not allowed when the device is a client. That's the only difference. When a switch is a client, the only way you can modify the VLAN database is through VTP. A server switch allows you to add and remove VLANs locally on the switch. A client switch does not. Okay? There is another difference, but I'm not really going to get into that. I don't think it's that important. Transparent mode, because it's the preferred mode, let's talk about what transparent mode does. First of all, there's no VLAN.dat in transparent mode. Anything that's stored in VLAN.dat moves to the running config. Because transparent mode essentially, not quite, but essentially is disabling VTP. Because transparent switches do not send advertisements. Transparent switches do not synchronize to the domain. If they receive an advertisement, they ignore it. And the only way to add VLANs to a transparent switch is manually. No, VTP is not covered on ICND 1. It's only covered on ICND 2.
I thought there were a couple questions.
VLANs and VTP are covered on ICND 2. Now for the new tests, they did put some VLAN stuff on the first test. But for the old tests, all the VLAN stuff is on the second test.
Well, that might have been last night wrong. Running together.
I just checked a fresh switch over version 15, and they made transparent the default mode. Well, that sounds good. It's about damn time. It's only taken them 15 years to do it. All right? Cisco has been publishing on their website that the preferred mode of VTP is transparent forever. I guess they finally decided to make it the default mode.
Follow their own advice.
Hmm?
They followed their own advice.
They followed their own advice, yeah. Now, it's not that VTP is not a good protocol, and it can be secured to a certain extent. But honestly, it's not really that necessary. Because how many times are you changing VLANs in your enterprise? Not a whole lot. From time to time, I suppose. But there are ways to secure VTP. VTP version 3 actually has authentication, like real authentication. VTP version 2, you can do a password, but the password is sent in plain text with the advertisement, so that's not that secure. The command that we use to verify VTP is show VTP status. Show VTP status. I can see version 2. The current revision number is 0, which means I haven't had an update to the database. Wait, I haven't had an update to the database, but I have 5 VLANs. Well, guess what? Those are the 5 default VLANs. Notice the domain name is blank, right? So this switch will join a domain if it sees it. Come on.
It will stay with servers, all right?
Oh, jeez. Just crashed. I'm sorry, what was the question?
It will stay a server once it joins the domain.
Yes. The mode doesn't change automatically.
Right.
I don't know why it just crashed. It's just stupid. Come on.
Hey, Daniel.
All right. As far as propagation goes, a transparent switch does participate in VTP. It doesn't participate itself, but it will pass advertisements down the line. So you can have transparent switches in between servers and clients. The transparent switch will ignore the update, but it will forward it to the client. I don't know why you'd ever really want to configure that, but it is something interesting to know. All right. And then these are just the configurations. VTP domain think tank, VTP mode transparent, VTP password. You can set the password, and you can set the version. And then on the last slide here, I just kind of gave you guys some of the details of the different modes of VTP. More for your information for reading later on if you so choose. You're not tested on it. Actually, I think you might see one question on using VTP for the extended range of domains or VLANs. You have to use VTP version 3 if you want to carry VLANs 1006 through 4095. VTP version 3 added support for the extended range of VLANs. All right. And then enhanced authentication. That's probably the biggest change in VTP from version 2 to version 3 is the fact that it supports authentication. Authentication is no longer done with plain text. We use an MD5 hash and a secret key, much like routing protocols use. All right? So, I told you that was a fast chapter. Chapter 6 is fast as well, but I think we'll just go ahead and pause right now.